As you watch Halima's lesson on electrical conductors, consider the two sides of the teaching and learning coin. The most important side is the progress the students make in their learning. Look for things like their engagement and attitude, their interest in the topic and how they seem to feel. On the other side of the coin, think about what the teacher is doing to get this impact.
Okay, children. Today in science we will be doing an investigation, and your learning intention is, can I show and explain why some materials are good electrical conductors and some are not? The two main things you're going to show, and the second one is explain, okay? Now, our vocabulary. Everyone ready? Electrical conductor.
Electrical conductor.
And what is an electrical conductor? Kadir?
An electrical conductor is when it lets electricity pass through.
Very good, well done. Electrical insulator.
Electrical insulator.
Alex, what's an electrical insulator?
It doesn't let heat pass through.
Well, that would be a thermal insulator. How about electrical?
Electricity.
Good girl. Okay, electricity.
Electricity.
Now, electricity, we'll be going into this a bit more detail. It's the flow of electrons in the same direction. How will this investigation help us today? If we're trying to find out which materials are good electrical conductors, how will this help us in real life? Have a little think about sockets and plugs and what they're made of and about safety. Have a little chat in your groups, please.
Wires are made out of inside the
Plastic metal.
no, metal and outside the plastic, so you don't get electricity.
Okay, who can help me out? Or if you've got your own idea, that's absolutely fine. Danielle?
It's like the plug is made of metal, and all the plug socket does is circulate electric. So you put the plug in, and because it's metal, it will go through the plug in.
Good. How about around the metal? The metal's inside, but what's around the metal?
It's plastic around the metal because if you touch it, you get electric shock.
Good, so it's for safety reasons. So we'll know which materials are on plugs or other electrical appliances, and we'll know why, okay? Let's see, how about a screwdriver? Why do you think I've put screwdrivers on there? Daniel?
If you touch like something electrical with a screwdriver, like, and there's no like other type of material on the end, but you can get electric shock. But
Good.
like when there's like a rubber or plastic bit on the end, you can't really get electric shock because that's an insulator.
Good, well done. If you did hear Daniel, I'm just going to say a tiny bit of yours again, Daniel. So we've got this part, which is a part we might actually put into a device that's electrical. And then we've got a plastic or a rubber part. Well done, Daniel. That's an insulator. We know this, and we'll be testing it again. So we don't get an electric shock, so the electricity or the electrons don't grow and give us an electric shock, okay? Activity 1. I'd like you to make a complete circuit, which means to make the bulb light up using only 3 components. So I'm going to give you 2 minutes. If you find one way, see if you can find a different way of making a complete circuit with only 3 things. Before you start, it's the bulb with only 3 things. Please don't touch the other bulb. 2 minutes starts now.
You need to turn up a wire into the battery.
Good, so we've got one part of the wire attached there. Good. So how are you going to connect that battery to that bulb? Where else could you try it? Think of other places in the bulb. Good, well done. That's one way you found. Can you find another way?
Yeah.
Do the bottom. You put the fish in the bottom.
Yeah, natural.
Yes, that's up 2 ways.
Okay. Hands up if you managed to make a complete circuit. Very good, all of you. Now, let's draw a picture. Who can tell me? Actually, let's get someone to draw my wires. Who can come and draw? This is my bulb. I don't have my battery on here. Who can draw my wire and my battery? Amna? come and draw it for me. Good, so that's is that a battery or wire?
Clip.
Oh, sorry, clip, okay. Good girl. And what goes there?
Battery.
Good, perfect. Okay, let's have a look. Hands up if you agree with Umnas. And it's fine to disagree, remember? In year 6 and year 5 we disagree, but we also accept that Umna had a good try. Shannon.
Disagree because I think that both of the wire and the battery are in the same place.
Good girl. Chloe, come and show me where was one of our wires attached to the bulb? Come and show me. Point to it. Good. At the bottom, well done. So that's where our battery was attached, at the bottom. There are electrons in a circuit moving in different directions. So within a circuit, they're going in all different directions, okay, not the same direction. However, when you put a battery into the circuit, all the electrons will flow the same way, and that is what causes the electric current, electricity. Now, a good way to show you that is we're going to model it, okay? So we'll take a few minutes. All I want you to do, number 1, pick up a beanbag. 2, without talking, get into a nice circle. Okay, well done, you did that really well. Now, I'm going to demonstrate to you how electricity works, the flow of electrons. In your hand are beanbags, but they're not for now in our science lesson. We're going to pretend they are electrons, okay? Now, in a circuit, we've got a circuit going. Can you close the gap, please? Yep. And we have a bulb over there which hasn't lit up yet. You are going to have your electrons moving around in all different directions because that's what happens in a circuit. So, have them moving whichever way. Pass them on whichever way you choose to. Good. Anyway, you can pass it that way if you like, Motor Speaker. Good. Now, listen while you're doing that, please. When I put the battery in, I want all my electrons to flow my right-hand side, that's anti-clockwise, okay? I haven't done it yet, keep going. So it's going to go anti-clockwise, and then my bulb should light up. Okay, battery being inserted. So everyone should be flowing this way, and me. There you go. And once it gets to Paulette going in the right direction, good, Paulette, it should light up. Keep going the same direction. Keep going, Chloe. Can you all see that it's going the same way? So what has happened? Have a little look. And stop. Okay. I want you to put the beanbag just on your table. We don't need them again for now. Go to your tables and discuss what just happened, how the electricity works.
Because the battery pushes it.
Yeah, and it goes, when the battery is not attached, nothing happens. It just goes all over.
So if they go the same way, the bulb lights up because the battery pushes it.
Excellent thinking. Let's have what you've spoken about on your table.
What happened is that we first just passed the beanbags anywhere, so the
Good.
bulb didn't light up. So you need to do it in the same way to make the bulb light up, or it won't get the power that everyone's giving it. So that's why the bulb won't light up.
And what had to be inserted into the circuit for the electrons to go in the same direction?
The battery and the bulb.
Excellent. The battery. Well done. First of all, how can we test if a material is an electrical conductor, Danielle? What can we do?
I think we're going to get 3 wires,
Okay.
a bulb and a battery, and then connect it to different items and see if it lets it pass electricity around to light the bulb.
Very good. That's exactly what we're going to do. Fantastic. But before we do that, okay, we are going to do a prediction of each item. And what you are going to do, you've got a table, and you're going to write the material in and make your prediction before you test anything. And then you've got to actually test it out and then tell me, was it an electrical conductor or was it not? Yes or no, or that's all you need to write, okay? Let's see, 5, 10, 15, 20 minutes. get started, please.
What do you think would be the best thing?
I predict
It would obviously be something
metal.
the silver coin.
Because,
Metal, yeah.
because I've read it in the book. I've read it in the book that silver is the best conductor because it lets electrons pass through very easily. So silver coin.
For some reason, just like when you put it in the oven, because when you take it out, it's not hot. Sometimes it is. Is it? Sometimes it is, but you're able to hold it. So would that mean it's let heat pass through it, or yeah, that would mean it's let heat.
That's about heat, though. We're talking about electricity.
True.
Yeah. Copper doesn't conduct electricity. It's only the
So
silver coin and the foil. That's my metallic. Not all metallic. I wouldn't say all metallic. I would only go for the silver coin, and then I'm only saying the silver coin foil. I don't really think the copper coin will do it.
yeah, I'm going to
Silver coin and foil as well.
What about the nail? Is it nail?
And the nail.
Okay, everyone should be moving on to the actual investigation, making the circuit.
Do it in order. Wood. Let's say wood here. To go clipped it. There's no way you can clip it. You have to hold it in the middle. The bulb is not lighting. Let's try a paper clip. A little tiny paper clip. Yes!
Okay, first of all, which ones were electrical conductors? I'm just going to call your name, you give it to me. Amna.
Paper clip.
Paperclip. Victoria.
Foil.
Foil. Iqbal.
Copper coin.
Copper coin. Asad.
Silver coin.
Silver coin. And anything else?
Iron nail.
Iron nail. Now, what do you notice about all of those materials? What are they? If we had to categorise them and group them, what are they? They are all metals. So, having a little think about the words electrons and flow and direction, how can you explain to me what was happening in that circuit, in that complete circuit when you put the metal in? What was happening to the electrons?
The electrons were taking the energy from the battery and the metal, which made the bulb light up.
Very close, but the electrons are not actually taking the energy. It is the energy. Electricity is like a form of energy, okay? So let's get someone to help. That was really good. Let's get some more detail in that. Chloe.
Well, the electrons were going all the same way, which made the light bulb light up.
Good. The electrons were moving in the same direction, which makes an electric current, okay? All groups need to write down why it's a good electrical conductor, the metals, and why the non-metals are not electrical conductors. You've got to tell me both. And then you're going to demonstrate using your beanbags in your groups.
I found out that metals are good electrical conductors because they let electrons pass through, and they are passing and pass through and they pass through the same direction. Non-metals are not good conductors because they were not going the same way and they were only vibrating.
Now, in the middle of your table, I've put a different object that we've just tested out. There's iron, coin, plastic, and wood. And you're going to show me what's happening. Are there electrons passing through? Well, we've got an electron there, okay? So you've got to tell me, explain, and show to me what's happened to the rest of the group, okay? I'll give you about 3 minutes to discuss it. I'll give some more bean bags. So, this is a coin. Good. Well, you should really have an electron. Do you not have electrons in your object? Yeah, you do. So, is Shannon not in the circuit then? Are you sure? Because Shannon doesn't look like she's in the circuit. Maybe hold it with one hand.
Wait.
Okay.
Hold it.
Excellent. Let's get everyone to demonstrate what's happening. Okay, over here. Good, you're actually just, small vibrations within the atom. Good. Where the rest of the metallic objects, we've got the flow of electrons in any order. Perfect. Give them a round of applause. How about about what will happen. Have a little think about the coin, what object the coin is. Hold on, the bulb would like some too. Good. Can this group explain to everyone what's going on here? What are the electrons doing into the coin?
It's moving the same way.
And what about the coin? Is it going through the coin?
Yes.
Good. Why?
Because it's metal.
Excellent. Well done. Sit down. Give them a round of applause.